Greetings everyone and welcome to Time and Space. In today's episode we delve into the greatest rift in human knowledge. The division between the immense and the minuscule. Imagine that the universe follows two distinct instruction manuals that don't speak to each other. On one hand, general relativity successfully explains the dance of the stars and gravity. On the other, quantum mechanics governs the chaotic world of atoms. Both theories are brilliant, but they contradict each other when we try to unite them. Einstein dedicated his final years to searching for a theory of everything, without success. Is our reality a single piece, or do we live in a broken puzzle? Without further ado, let's begin. To understand the universe on a large scale, you must first change your concept of gravity. I bet Einstein taught us that this is not an invisible force that pulls objects. In reality, it is the very geometry of the cosmos. Imagine space and time united in a single flexible mesh. If you place a heavy ball in the center of a trampoline, the fabric deforms and sags. That sag is the key. A smaller object will roll towards the ball, not because it is attracted by a magnet, but because it follows the curvature of the terrain. This four-dimensional structure is known as spacetime. Planets and stars do not float in a vacuum, but rather mold the fabric on which they rest. The most astonishing thing is that this deformation also affects the clock. According to research, time passes more slowly in places where gravity is more intense. This geometric vision successfully explains the movement of galaxies and the deflection of light. It is an elegant, smooth, and predictable world. However, this absolute harmony is about to break when we try to look inside matter. Upon descending into the world of the minuscule, Einstein's harmony completely disappears. Here, reality is not fluid, but rather fragmented into individual packets of energy, called quanta. Imagine that nature, instead of being a silk painting, is a mosaic formed by rough and indivisible pixels. This scenario is the standard model. In it, matter is built with fundamental pieces, such as quarks and leptons. These particles interact through three invisible forces: electromagnetism, which gives us light, and the strong and weak nuclear forces, which hold together the heart of atoms. The messengers that carry these instructions are bosons. But what really confuses scientists is the lack of absolute certainty. In this quantum casino, superposition exists, where a particle seems to be in several places at the same time. Nothing is certain until you measure it. This microscopic chaos operates with astonishing precision, but completely ignores the rules of gravity that we previously knew. Order and chaos coexist in the same universe, but they refuse to speak the same language. The problem arises when you try to force these two theories to work together. When applying quantum rules to gravity, the equations return impossible results: infinite numbers. In science, an infinity is not a very large value, but an error indicating that mathematical logic has completely broken down. This disaster occurs due to the visual clash between both worlds. Relativity demands a smooth and continuous mesh, while the quantum world is a boiling cauldron of violent fluctuations. Imagine trying to draw a perfect line on a surface that vibrates furiously. It is simply impossible. This conflict is inevitable in extreme places, like black holes. There, a gigantic mass is compressed into a tiny point, called a singularity. It is the battlefield where gravity is so strong and space so small, that both theories vie for control simultaneously. Unlike other forces, gravity resists renormalization. This is the mathematical process that usually cleans up absurd results in other areas. This absolute breakdown leaves us facing an invisible wall. It forces us to accept that our current tools are insufficient to understand the origin of everything. In the face of the chaos of infinities, an elegant proposal emerges called string theory. Imagine that everything that exists is made of tiny threads of energy that vibrate restlessly. Instead of dimensionless points, the universe is composed of microscopic strings. As happens on a guitar, the frequency of the vibration determines which particle we are observing at any given moment. If the string vibrates in one way, we perceive an electron. If it does so differently, we see a photon. This idea is fascinating because gravity finally appears as another vibration. By integrating it in this way, the mathematical errors disappear. The large and the small begin to speak the same musical language. However, this harmony requires a complex scenario. For the calculations to be correct, the universe must have 10 or 11 dimensions. We do not perceive them because they are folded microscopically far from our everyday reach. According to this vision, reality is not a static mesh, but a vibrant symphony that occurs in invisible spaces. While string theory proposes vibrating threads, there exists another equally powerful vision called loop quantum gravity. Imagine for a moment that space is not an empty, smooth stage. In reality, it resembles more a mesh woven by tiny links. According to this theory, space itself has atoms. This means that you cannot divide reality infinitely. There is a limit, a minimum unit, beyond which the concept of place ceases to exist. These basic components are intertwined loops of energy. When joined, they form what experts call spin networks. What is most revolutionary is that this idea eliminates the concept of a background upon which everything occurs. The universe does not happen within space. The universe is the result of these connections. If strings are the music, loops are the links of a network that creates the geometry of the cosmos. Unlike other proposals, here you do not need hidden extra dimensions. You are faced with a granular, finite reality. By understanding that space is something built piece by piece, gravity integrates naturally into the quantum world. The vacuum is not really empty, but rather it is a vibrating structure that sustains existence itself. The solution to the great conflict could be hidden in the tunnels of the cosmos. Decades ago, Einstein and Rosen described wormholes as shortcuts connecting distant points of spacetime. At the same time, quantum entanglement was analyzed. This is that strange connection where two separate particles react instantly as if they were one. Today, a revolutionary hypothesis called Emergent suggests that these concepts are the same. What was once seen as a geometric bridge could be the large-scale manifestation of entanglement. That is, the invisible threads connecting atoms would be microscopic versions of spatial tunnels. This idea transforms your vision of reality. It suggests that the geometry of the universe is born directly from quantum information. If this is true, gravity is not just an external mesh. In reality, it would be the result of how particles are connected to each other. We are facing a literal bridge between relativity and the quantum world. Here, the structure of the cosmos is pure entanglement. We are reaching the limit of what we know. Currently, scientists are proposing an idea that seems like science fiction. Space and time are not fundamental. In reality, they could be side effects of something much deeper. We call this concept emergent reality. Imagine temperature. A single molecule has no heat, but when millions of them collide with each other, thermal sensation emerges. Similarly, the fabric of the universe could be born from the interaction of quantum data. Here, the holographic principle comes into play. This theory suggests that our entire three-dimensional world is a projection of information stored on a flat, two-dimensional surface. From this perspective, You and everything you see are like the hologram on a credit card. The basis of existence is not matter, but information. Various experiments are currently seeking to confirm whether space has this invisible digital grain. We are living through a total transformation in our understanding of the cosmos. We are no longer just seeking physical laws, but the source code that writes reality. The mystery continues, but each step brings us closer to understanding that we are part of an amazing information network. Our journey from the curvature of space to the digital code of the cosmos demonstrates that the search for unity is the greatest human challenge. We have seen how gravity and atoms seek a common language. Although the final answer remains hidden, your curiosity is what keeps science alive. If you are passionate about discovering the secrets of physics, subscribe to explore more mysteries with us. The universe always has something new to teach you. Always stay very curious.